So hi everyone, today I will be presenting different examples on the sound intensity in decibels. So these are word problems that involves calculating or finding the sound intensity of a certain object or any word problem that is related or that involves sound intensity and decibels. Now for the first problem, we have here, during a fireworks display, a rocket explodes high in the air above the observers. Assume that the sound spreads out uniformly in all directions and that reflections from the ground can be ignored. When the sound reaches listener 2 in the figure below, who is R2 equal to 640 meters away from the explosion, the sound has an intensity of I sub 2 equal to 0.10 watts per meter squared. What is the sound intensity detected by listener 1, who is R sub 1 equal to 160 meters away from the explosion? Okay, now for this problem, what we are going to do first is to write our given. So right here, our given. So we have our R sub 1, okay, that is 160 meters. 160 meters. R2, that is 640 meters. I sub 2, or our sound intensity for listener 2, that is 0.10 watts per meter squared. And we are going to look for our sound intensity that is detected by our listener. So that's our given. And okay, so you can see here based on the figure our R1. So this is R1, this is our listener 1, this is our listener 2. So basically yung R natin, it indicates the distance, okay, or how far is the listener from the source of the sound. Okay, now for the next step is we have our formula for sound, for sound intensity. Okay, indicate it as I equal to power over area. Okay. So the area for the surface area of the sphere, okay, so since we are assuming na itong explosion dito, okay, it looks like a sphere. So yung surface area ng sphere, yung kukunin natin. So we have your P. The surface area of the sphere is equivalent to 4 pi r squared. Okay. So that is the default. Okay. Ito yung standard the surface area formula for the sphere. Okay. Now, for the next step is we are going to write, okay, our equation. So we are going to compare or get the ratio of our intensity 1 and intensity 2. And then our I1 is equivalent to P 4 pi r sub 1 squared. Okay, so the distance of our listener 1 from the explosion, and for the I2, it's equivalent to P 4 pi r squared. Okay, but r sub 2, okay, the distance of our listener 2 from the explosion. Now from this equation, this is equivalent to P over 4 pi, this is R1 squared, multiply with the reciprocal of the denominator. Okay, so that is presented in your, I think that's in Gen Math or Algebra. Okay, so babalik na rin natin, or we will get the reciprocal of our denominator. So nasa itaas na yung 4 pi r sub 2 squared over P. Now with this equation, magpo-cross multiply tayo, maka-cancel out si P, maka-cancel out si 4 pi. Okay. We will be left with r sub 2 squared over r sub 1 squared. Now we have derived a relationship of the two. Okay, this is I1 I2 equal to R sub 2 squared over R sub 1 squared. Okay. Now, what we are going to do with this equation is we will transpose this in order for us to come up with the equation or the formula where we can get the value of I sub 1 or our sound intensity that was detected by listener 1. So what will happen to this equation is i-multiply ko both sides by I2 or I sub 2 para ma-cancel out siya dito na side. Tapos malilipat siya dito na side. So yung maiiwan na lang dito sa kabilang side is our I1. So example, I'm sorry. So this is how it will look like. Ayan. Then I will multiply this with I2, I sub 2, and then I will also multiply this with I sub 2. So dito maka-cancel out, matitira si I1. So equation na natin for I1 becomes I2 times R sub 2 squared over R sub 1 squared. Okay. Now, plugging in our given, ilalagay natin yung mga given values natin. Our I2 is 0.10 watts per meter squared. Yan. Times our R2, that is 640 meters squared. So we have to square this, and then for R1, that is 160 meters squared. So calculating this using your calculator, you will get 1.6 watts per meter squared. So this is now the sound intensity that was detected by listener 1. Okay, now for the next example is, these are problems naman that involves the decibel scales. Okay. So we have here a 10-minute exposure to 120 decibel sound will temporarily shift your threshold of hearing at 1000 Hz from 0 decibel up to 28 decibel. Now 10 years of exposure to 92 decibel sound will cause a permanent shift to 28 decibel. Now what sound intensities correspond to 28 decibel and 92 decibels? Okay. So for this problem, we are given two sound intensity levels. That is the 28 and the 92 decibels. Now we are going to look for its corresponding sound intensities. Now to look for the sound intensities, we will first write our given. We have here, since we are going to look for the sound intensity for I20E, our beta is equivalent to 28 decibels. Okay, and then for the sound intensity for the 92 decibels, our beta is 92 decibels. So itong 28 dito at saka 92, it is only an indication that we are going to solve for the sound intensity that corresponds to 28 decibels, so 28, and then 92 decibels naman is 92. So yan yung purpose ng subscript. Now, our I sub naught, or our I naught, or our initial sound intensity is equivalent to 10 raised to negative 12 watts per meter squared. So this is a standard sound intensity for the threshold of hearing at 1000. So this is already a default or a constant value. Yan siya. So when you see, or in the problem, or when you have this threshold of hearing at 1000 Hz in your problem, so it means that our I sub naught, or our initial intensity, is equivalent to 10 raised to negative 12 watts per meter squared. Now for the formula that we are going to use is, this is the general formula for beta. That's 10 decibels, okay? And then we have here log of I over I sub O. Now, since we are looking for the I, or this I, so we have to transpose this equation. So this is actually equivalent to I over I naught equal to 10 raised to beta divided by our 10 decibels. So this is from the relationship 10 log x equal to x. So I think I'm not really sure if what part of your mathematics subject is this one, but I am pretty sure that you already have discussed this in your previous maths. So, diretso na lang ako doon sa derivation or doon sa exact derivation of this formula or this equation to this equation. Now, since we are going to look for I, we will multiply both sides by I naught. Para makancel siya dito, so yung I na lang yung matira sa isang side. Now, we have I is equal to I naught times 10. Okay? That's 10 raised to beta divided by our 10 decibels. So, this is now our equation na gagamitin to solve for the sound intensity for 28 decibels and 92 decibels. So the next step is for I28, this is for the 28 decibels. Our I naught is 10 raised to negative 12 watts per meter squared, okay, times 10 raised to our beta, that is 28 decibels divided by 10 decibels. So this will actually give us 10 raised to 12 watts meter squared times 10 raised to 2.8. Now multiplying this using your calculator, we will arrive with 6.3 times 10 raised to negative 10 watts per meter squared. Okay. Now for the I92, okay, we will still do the same process. That's 10 raised to negative 12 watts over meter squared, okay, times 10 raised to, that's 92 decibels divided by 10 decibels. This will give us 10 negative 12 watts meter squared times 10 raised to 9.2. So this will give you 1.6 times 10 raised to negative 3 watts meter squared. So this is now our corresponding sound intensities for 92 decibels, and this one amount is for the 28 decibels. Okay, now for our next example, this is another different approach in solving problems involving decibels. So we have here an audio system 1 produces an intensity level of beta sub 1 equal to 90 decibels, and system beta sub 2 produces an intensity level of beta sub 2 equal to 93 decibels. Now the corresponding intensities in watts per meter squared are I1 and I2. Now determine the ratio I2 over I1. So here, yung gagawin natin is we are going to determine ratios. Okay, so the first step here is to write the given beta 1, that is 90 decibels, and beta 2, that is 93 decibels. Now we are going to look for the ratio I2. Sorry, it's I2 is to I1. So to look for the ratio, the first step is we have to subtract B1 by B2. Now take note that the formula for our beta or for our intensity level in decibels is 10 dB log I over I. So what we are going to do is if we have this equation, so it will follow 10 dB log I1 over I0. I'm sorry, that's I2, not I1. So since we talk about beta 2 first, and then minus 10 decibels log I1 over I0. So applying your knowledge in mathematics, if we subtract the two, we are actually going to have this type of equation. So this will become I2 over I0 divided by I1 over I0. So itong subtraction na ito, when we are talking about logarithmic equation, okay, this will be, or this is equivalent to the division of this variable by this variable. So kaya naging I2 over I0 divided by I1 over I0. Now expanding this further, transposing or transforming this equation further, this will actually give us 10 dB log. So I2 over I0 times the reciprocal of I0 over I1. So ito magka-cancel out. So matitira is I2 over I1. So we now have 10 dB log I2 over I1. Now since yung goal natin is to look for the value of this one, okay, so since this is the ratio, ito yung hinahanap natin. We are going to transform this equation. So yung beta 2 natin, ayan, minus beta. So ilalagay ko muna, or isa-substitute ko muna yung values, that's 93 minus 90 equal to 10 dB. Okay, so this is actually decibels, yeah, decibels log of I2 over I1. Okay, so 93 minus 90, that's 3 decibels equal to 10 decibels log of I2 over I1. So dividing both sides by 10 decibels. So dito magka-cancel out. So dito 3 divided by 10 decibels. This will give you 0.3 equal to log of I2 and I1. Now using the relationship, yung relationship also na present ko on the previous problem, yeah, relationship of 10 log x is equal to x. Yeah, this will actually give us I2 over I1 equal to 10 raised to 0.3. Now, if you solve this, 10 raised to 0.3, it will give you 2.0. So this is now our ratio. Or I will write it I2 over I1 equal to. So this is now our answer. So what does this mean? So ibig sabihin that doubling the intensity changes the loudness only by a small amount of 3 decibels. Now for the last example, we have here, what is the intensity in watts per meter squared of 85 decibel sound? So what we're going to do is to look for corresponding intensity of the 85 decibel sound. So first, we are going to write our given, that's beta, equivalent to 85 decibels. And then we also have threshold of hearing at 1000 hertz, that's 10 raised to negative 12 watts per meter squared. This is actually an implicit given. Okay? Yung given na hindi natin nakikita sa problem, but we consider it as our given. Okay? So our formula to be used is the I equal to I naught 10 raised to beta over 10 decibel. So this actually came from our general formula, that's beta 10 dB log of I over I. So you can use this directly without undergoing the process of derivation. So you just memorize or just familiarize this equation. So now I will plug in the values. This is 10 raised to negative 12 watts per meter squared, times 10 raised to 85 divided by 10. This is 85 dB. So this will give us meter squared times 10 raised to 8.5. So if you calculate that, it will give you 3.16 times 10 is a negative 4 watts per meter squared. So this is now our intensity in watts per meter squared for the 85 decibels. Okay, so that's all for today, or that's all for this topic. We will have another set of examples for the Doppler effect. So thank you for watching. If you have clarifications about this topic, please feel free to approach me through my Facebook Messenger. That would be all. Thank you and God bless.